So I was saying that there is a water सीमेंट रेशो जिससे पानी का कंटेंट हम निकालते हैं, तो वो पानी का कंटेंट that's without the absorbed water which are taken by the aggregates. So we say that it's fully saturated aggregates that we use in concreting. They are saturated with water. उनमें पानी 100% the water has gone within those particles. So we are determining the water content except this amount. So this is, then we have effective water. So what is effective water? So it's the effective water content actually. So, or you can just simply say effective water. Effective water is the water that is required for aggregates to be saturated and surface dry condition. So the water in the mix that you are using, in the concrete mix that you are using for the aggregates, जो कि पहले ही saturated है 100% and they are surface dry condition. In the surface dry condition, they have no adsorbed water. So that's the effective water content you are using in concrete. But if you use the term free water, it can also be called as, apart from what is the free water within the concrete, there is another free water, that is the excess water that is absorbed. So how do you get free water? You can easily get free water. आप क्या करोगे, आप एग्रीगेट के पार्टिकल्स को एक पहले सोक करोगे पानी में पूरा. ये पानी का बीकर है, इसमें मैंने इनको सोक किया. देन आई टेक आउट दीज एग्रीगेट्स, एक पैन में एक ट्रे में रखकर उनको ओवन में डाल दिया. आई प्लेस देम विद इन एन ओवन. In a tray, these aggregate particles are then placed in a tray, एक ओवन में डाल देते हैं. In that oven, the temperature is kept around 100 to 200 degrees Celsius over a period of 24 hours. तो उनमें से absorbed water भी बाहर निकल जाता है. तो जो उनमें पहले absorbed water था, उससे पहले मैंने इनको पानी से निकाल के I just surface dry them with air drying for half an hour. उनका वेट लिया एग्रीगेट पार्टिकल्स का, कितना उनका वेट है. उसके बाद ओवन में 24 घंटे 100-200 डिग्री सेल्सियस पे रख के देन अगेन आई रीवे देम. तो उनमें से एब्जॉर्ब्ड वाटर भी अंदर से निकल जाएगा. तो वो फ्री वाटर है. दैट इज फ्री वाटर. That's how you can get the free water from within the aggregates. So it is basically in order to know how much actual water we require for concreting. अगर मैं फ्री वाटर भी ले रहा हूं, अगर एग्रीगेट्स टोटली खुश्क है, तो मैं साइट पे ये मान के चलूं कि इसमें फ्री वाटर कंटेंट कितना परसेंटेज होगा, तो उतना पानी में मुझे थोड़ा सा और ऐड करना पड़ेगा कंक्रीटिंग के लिए. क्योंकि अगर वो पूरे खुश्क हो गए होंगे एग्रीगेट्स, देन यू आल्सो रिक्वायर to add the free water to the water content. That means you also need to add the absorbed water. जब आप साइट पे कास्टिंग कर रहे होंगे, एज एन इंजीनियर यू हैव टू टेक द कॉल कि पानी का कंटेंट खुश्क एग्रीगेट्स के लिए मुझे कितना रखना है. अगर वो बिल्कुल ही इट्स ऑल वेट, द एग्रीगेट्स आर ऑल वेट, उनमें बाहर से भी पानी है, देयर इज एन absorbed water, then you just limit yourself to the effective water. But you can even decrease it further. The effective water you can still decrease it further अगर वहां पर बिल्कुल वो particles उनमें surface water भी हो. So you can decrease below the effective water. So this is to know how much water you actually require at the site. Now there is one more term, that is gel space ratio. Gel to space ratio. I've already discussed this briefly, but I'm going into the detail now. What is gel and what is spaces? We already have discussed this. This is the cement paste. This will be a cement paste around the aggregates. There will be cement paste like this. So for example, you have this as the cement paste, and these are the aggregates around them. Within the cement paste, I already described, there are pores, which are the gel pores. And then what is left, there might be certain spaces, which will be empty spaces within the cement paste. So it will be totally empty spaces within this. So gel to cement, there is a space in between. So this is gel and this is space. So there is a ratio between the two. Between the volume of the gel. So it's the ratio of volume of hydrated cement paste, which is the gel, to the spaces, or the sum of the volumes of the capillary pores and hydrated cement. So you can take this ratio in terms of this as well. It's the ratio of the hydrated cement paste to the sum of the volumes of the capillary pores plus the hydrated cement again. So it's actually giving you the volume of the hydrated cement paste within the, so gel space ratio we can take in terms of this, or you can simply say it's the amount of gel volume. It could also be classified in terms of this to the amount of the spaces in between. But it's not easy to determine the spaces. Technically, practically, it's not easy to determine the spaces. So that's why we give an expression like this: ratio of the volume of the hydrated cement paste to the sum of the volumes of the capillary pores, and sum of the volume of the capillary pore plus hydrated cement is total volume. And so ratio of hydrated cement paste to the total volume, you can classify this as also the gel space ratio in terms of this as well. So if now we have, it's denoted by, I'll write it down like this, R. You can also classify this as R, this ratio. There are various expressions. This is an empirical equation developed for this. It's equal to 2.06 VC, which is the volume of the gel, divided by VC into alpha plus W naught by C. Here VC is volume, its specific volume of gel or of cement. W naught by C, you know, it's a water cement ratio here now. W naught by C is water cement ratio. W naught, you know, it is water content in terms of volume. Alpha is fraction of cement. That has been hydrated. So it's a fraction of cement, itself a ratio. denoting how much amount of cement has been hydrated. So this is the equation, and R that you are getting finally from here, it's the gel space ratio. This is a empirical equation for determining the gel space ratio. So if Vc is known, the volume, the specific volume of the cement, because we know that the density of cement is 3.16. So up till around 3.19. So if I take the higher value of it, if Vc is known, if it's 3.319 ml per gram, then the equation which I was just writing down, R, would be equal to, it would be 2.06 into Vc, that will be 0.67657 divided by, again Vc is 0.319, the equation we just wrote, into alpha plus W naught by C. So this is the equation of the gel space ratio. Now, how are gel space ratio and strength of the concrete related with each other? The strength of concentration of solid particles of hydration of cement in the space available for their products decides the strength of the concrete. The overall strength of concrete. Now, let me explain this. अगर आपके पास एक कंक्रीट है और उसमें जेल कंटेंट ज्यादा है, if R value is more, that means, और spaces कम है, मतलब voids कम है. Spaces are less, voids are less. Gel is more, that is hydrated product is more, solid particles are more. Will it have more strength? Yes, it will have more strength. So greater is R value, greater is the strength of concrete. So gel to space ratio actually also decides how much is the strength of concrete. But again, the amount of gel would be decided by the water content. So जितना पानी उसमें होगा, available for hydration within a maximum limit, तो उतना वो, अगर आप पानी उससे ज्यादा डालोगे तो उसमें ज्यादा स्पेसेस बन जाएंगे, क्योंकि पानी will remain within the spaces that will not be available for hydration. तो पानी आपको एक ऑप्टिमाइज कंटेंट, एक बराबर मिकदार में you have to add it. अगर ज्यादा डालोगे तो वो पानी voids बना लेगा, खुद ही voids बना लेगा, क्योंकि वो it will take its space. So ultimately it will evaporate and it will leave voids, so it will leave spaces. अगर पानी कम डालोगे, it will not be available for hydration. So water has to be in a proper concentration that you are actually adding. So the strength will depend on the gel to space ratio, so in turn depending on the water cement ratio. तो हम इसको in terms of gel space ratio भी strength को classify कर सकते हैं. So the compressive strength FC, you can have an equation in terms of this, is equal to 234. This is again an empirical equation. R cube. FC is 234 R cube. R is this, the gel to space ratio. So again, this equation was given, this was given by Powers. The scientist is Powers et al. So there were certain scientists also involved in developing this equation. Apart from Powers, et al. Means there are more scientists. So FC is 234 R cube. So thereby the compressive strength and उसके बीच में जो gel to space ratio के बीच में जो equation है, तो उसके हिसाब से ग्राफ ऐसे बनता है. This is strength FC and this is gel to spaces. So at small amounts of gel, so if this is 1, gel to space ratio 1, this is around 0. So when you have 0 gel, the strength will be 0 because there is no solid particle. When there is more and more gel with respect to the space, the strength keeps on increasing, and then actually it's increasing in a cube. This is cube equation, so it's not a quadratic. This is a cubical equation, then increasing cubically, a polynomial of 3-degree order. So you can also classify the strength in terms of the gel to space ratio. Then it also depends upon the porosity of the concrete. Now, what is the porosity of the concrete and how does it depend on the porosity? And what is porosity, first of all? This is the last topic I'm taking up today. What is porosity of concrete? It is the volume of water pores within the concrete to the total volume of concrete. Simple definition, you have volume of pores with respect to the volume of the total concrete. But how do you determine the total pores within the concrete? So you use the permeability methods to determine the porosity of the concrete. I discussed this briefly already. So we at pressure, हम उसमें पानी concrete में डाल देते हैं. The water goes into the pores, and then you reweigh it, and you check how much is the weight of the water that has gone into the concrete, and what was the initial weight of the concrete. So, or you can do the reversing. You can fill it up by keeping the concrete in water for a long time. उसमें absorption हो जाएगी. The concrete will go into the pores, and then you remove it by keeping it to the oven for a long time, greater than 24 hours. And then you can note down the amount of the water that has gone into the pores, and knowing the density of the water, you can determine the volume of the pores within the concrete. So this is porosity, and उस porosity पे dependent है आपका concrete की strength of concrete. I just explained to you is dependent on volume of voids. Simple. You have a total volume of voids within the concrete, and the strength will be dependent on the voids. जितने voids ज़्यादा होंगे, spaces ज़्यादा होंगी, gel spaces between the gels will be more, so strength will naturally decrease. You do not want the volume of voids to go up, so it's inversely proportional to the volume of voids. तो voids के अंदर सिर्फ पानी नहीं होता है. There are other things. There is entrapped air within those voids. There is capillary pores which may be filled with water or which may be without water. Gel pores which are filled with water. Entrained air, which is the air which is remaining within the cement paste between the gels. So these are all together the voids within the concrete. So it's not easy to determine all these four, and how do you get them? Then you have to get them analytically. It's not possible to get them completely experimentally. कि entrapped air कितना है, capillary pores कितने हैं, gel pores कितने हैं, because maximum you can go with the permeability method which I told you. आप पानी को capillary pores के अंदर ले सकते हो, but you cannot take them the water within the gel pores, and जहां पर entrained air cement paste gel pores के अंदर है, क्योंकि वो नैनोमीटर में होता है, तो वहां पानी पहुंचना even with absorption is not possible. So you cannot be able to determine the amount of voids within the concrete at a given stage, the total number of voids. So there are various processes to determine the how much is the voids within the. So Now, what does this depend on? Your strength is dependent on the porosity as well. Uh, and thereby, if the porosity is more, your strength will be less. If your porosity is less, your strength will of the concrete will increase. I can show you how we determine the volume of all these, but probably we might do a question on that in one of the classes. So FC is actually dependent. There is a formula for this. FC naught 1 minus P raised power, you have raised power n. So again, this equation has been given by powers at all. So it's known as powers equation, where FC is the strength of concrete. It's dependent on FC strength of concrete with porosity P. FC is strength with porosity P. Then you have FC naught here in this equation, which is strength of concrete with zero porosity. That is, zero porosity means it has got the maximum strength. The pores are almost zero. The strength of the concrete with zero porosity, and P is here the porosity. What is N? N is a coefficient in this equation. Now that coefficient would depend upon various things. It would depend upon the shape, size of pores. It would depend upon shape of particles, solid particles. So this is the equation between the strength and the porosity. So you are seeing that it's minus P, so it's actually decreasing with respect to the porosity. Clear?